everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. This time we're talking about the week of May 30th, 2022, almost into June, almost into meteorological summer here. So if you followed the last couple of weeks, if you've watched the last two videos, and I don't know how you haven't, if you've seen one, I can't imagine that you don't just go back and watch them all again and again. We've talked about a little bit about geometry and about thinking about the celestial sphere, the inside of the sphere that is the sky above us there, and the projection of terrestrial, earthly coordinates onto that sphere, and thinking about what objects are directly overhead and looking north. And we had planned the next in that sequence to think about looking, we looked north 2 weeks ago, we looked overhead, and then going to look a little bit south this week. But we're going to take a break in that. We're going to shift directions here. We'll get back to that next week unless something else comes up and we move in a different direction. We've been talking about how these often mimic what I do in class and in courses, and this is the same way. We publish a syllabus at the beginning of the semester, and the class schedule, the list of topics on the syllabus is always tentative, because every now and then we just get interested in something and we have to spend extra time on it. We have to think about it, or something pops up. We're talking about something and it makes me think about something else. We're having a conversation about electron degeneracy in the cores of red giant stars and how that has changed the nature of the universe, and it gets us to thinking about working on something else, and we want to move in a different direction. And before you know it, we've spent 3 or 4 days, a full week of class sessions on this, and we have to cut something out. We have to do something different. These are no different. We think of something interesting. So here's what you can think about. You think of it this way. On one pole, I'm going to go out and read a blog post I wrote a long time ago, 8 years ago, about sort of unnecessary dichotomies, not just false dichotomies, okay? False dichotomies are one thing where, what I would have written about there was slow and steady wins the race. We teach kids all the time as if slow and steady are somehow fast and steady beats slow and steady every time. It is what I've found in my teaching of kinematics. And so, in any event, this is a dichotomy that doesn't make much sense. To talk about these things and to say, I work with my students all the time. So my students have a poster of me downstairs where I tell them, and they have lots of things that they claim I've said, and I don't know if I've said them or not, but probably. But this one I'm sure I have, because I'll walk in on them while they're working on code, and they say, hey, we figured out how to work smarter and not harder. And I try to explain to them patiently that it is possible to work both harder and smarter, that's a dichotomy that we don't really need to make. And so that if they really want to unlock the secrets of the universe, probably they need to work harder and smarter and harder. And so I think I tell students that all the time, to say, let's think about doing all of this stuff if we really want to figure out what's going on here. So in any event, oh boy, we're really off track now. So the idea was to say that we have a plan for what we're going to do, and we go off in another direction. And the non-generous among you might suggest that that's because I'm not organized enough, disciplined enough to stick to a plan. That's one pole of a spectrum, if you will. The other end of the spectrum that we're on over here would be to say that I'm just so dedicated to the idea of science, to the process of science, that when something new, interesting comes up, we have to follow that thread and pick at that thread and think about what's going on in that direction. And if you want to be generous about the way we approach this, and that's the same for these videos. I'll let you decide how you want to approach that. But in any event, we'll get back to thinking about geometry some next week. What we're going to talk about this week are the Tau Herculid meteors. And maybe you've read about this. Maybe by the time this video posts, you will have seen a little bit about this, because it's starting to pop up in news other places. I probably have a different news feed than many of you. I don't know. But in any event, let's think about comets. We've talked about this a lot over the course of these videos when we've looked at meteor showers, and to think about the idea that meteors and meteor showers come from debris left by comets. So here's what happens. We have the sun here, and comets, planets, we've been looking at the planets, we've been thinking about the planets. Planets have fairly circular orbits, right? I'll let you decide whether that's a circle or not, but they have these fairly circular orbits, with the sun at the center, more or less like this, and they're ellipses, but the eccentricity, the squishiness of the ellipse is very small. That's not the way it is for comets. Comets have a very, very flattened ellipse, and they tend to come in and do this. Okay, so that a comet orbit might look like that. It gets very close to the sun in here. And when it gets very close to the sun, that's when we see the comet, the tails, the stuff's boiling off the comet. And so there's two kinds of tails, and the solar wind, the material from the pressure from the sun pushing stuff out, is blowing that material away. And what will happen is if you've got the comet coming in here, the solar wind will blow the gas tail straight away, and what we call an ion tail. And so you get this blue tail that you see in fluorescence from the gases of the stuff being blown straight away. The heavier stuff, the dust, the grit that makes up that dirty snowball comet tends to form a curved tail as it falls back in orbit, or follows the orbit of the comet around, and this stuff falls back into the orbit. When we hit that dusty material, that's when we get a meteor shower. And we name that meteor shower for the position in the sky from where it seems to come. So the Leonids come from Leo, for example. So when Earth's orbit, suppose this is Earth's orbit right here, and we intersect that material right there. As we plunge into that, we're going to see all of this debris entering our atmosphere and burning up and coming from one point in the sky, and we call that point in the sky, that's the radiant, and that's where we name the particular meteor shower that we're talking about. So far, so good. Great. We haven't talked about what to look for in the night sky at all yet. It's beautiful. I'm going to see if we can go 25 minutes before we talk about what to look for in the night sky. It's called building the anticipation, the tension. So that's what we're doing right here. Yeah. Anyway, that's the radiant. When we hit those meteors, they come from this comet. So let's talk about these Tau Herculid meteors, which would imply that they should be coming from the constellation Hercules. And if you think back to last week's video, go back and watch it right now. Why not? We talked about this region of the sky. Hercules sits squarely between Boetis on one end and, the Summer Triangle, Vega and Lyra on the other side. So you got Hercules in here, you got Arcturus, and you got Vega here. And so the Tau Herculids would come from Tau, near the Tau star in Hercules, right here. So this, about 90 years ago, the comet that would give rise to these Tau Herculids was discovered. And its orbit was determined, and it was predicted when it would come back, and people calculated where this radiant of this meteor shower might be, and figured out, they called it the Tau Herculids that was in here. But we didn't see those meteors. To the best of my knowledge, I haven't done a lot of work on this, but to the best of my knowledge, by a lot, not a lot, I mean basically none. The Tau Herculids would come from the dust from this comet would come from someplace in Hercules, but we didn't see it. In fact, we lost the comet. We didn't see the comet. It didn't get if it doesn't get close to the sun, if it's a very small comet, and where it is relative to the sun, it's only boiling off stuff when the heat from the sun is causing it to boil off stuff. It's not doing it out here. You can't see it out here. And so we didn't see the comet for a long time, for 40 years probably. We didn't see the comet, and then there it was back, even though it had a 5-year orbit. So its orbit was relatively short, right? And so it's got this relatively short orbit. Then it pops back up. But then it's a small comet, and comets, one of the things we say in class is comets are not forever. If you're boiling this stuff off, that comet's going to go away. And comets are pretty small to begin with, a few kilometers across of frozen material, and it's boiling that stuff away. It's going to disappear after some orbits, 10,000 orbits, 5,000 orbits, something like that. You might see your comet boil away into nothingness and be nothing but debris around here that you never see again. Oh, that's a terrible thing. When you throw your Hagoromo chalk on the floor and break it into 2 small pieces like that. Very precious stuff to be doing that with. In any event, okay, here we go. So now, 30 years ago, this small comet, started breaking up into chunks. Pop, 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 pop. And each time after that, when it came back by, it was more chunks and more pieces. And so it was disintegrating right before our eyes as we watched this comet coming around. And so this comet has broken up into a lot of dusty material. And the last time, a while back, this thing broke up sort of explosively into several chunks and fired a lot of material out. And some models and some predictions suggest that material now should be very dense and very rich when we hit it this time around. And this is going to be May 30th, into the 31st. Somewhere right around midnight on the transition from May 30 into 31, you might expect to see a lot of meteors from this if these predictions are right. But they may be completely wrong and there may be nothing there. We may still fail to see the Tau Herculid meteors, okay? So don't get too fired up about this. There's a lot of stuff that goes on in astronomy. Meteor showers can be somewhat unpredictable, especially one that's never occurred before like this. This would be the first time to see. So that's a reason enough to go out and look for it, because you would be among the population of first humans to see this particular meteor shower. And how cool is that, right? And so you go out and you look for it, but it might not be there. It's very hard to predict. Comets themselves are very hard to predict. Well, history is littered with predictions from astronomers about comets that are going to be big and bright and beautiful, and got people pumped up and go out to look for that comet, and the comet just fizzled. It didn't boil off much material, and we didn't see much of it. Kohoutek comes to mind, right? To say that everybody was fired up to see that comet. Everybody wanted to go see that comet, and it just turned out to be and people were disappointed in what you saw, because it was hard to predict just how big and bright that comet was going to get. You start to see it out here, and as it gets closer and closer and closer, you think it's going to be fantastic, and it just doesn't happen. It just doesn't boil off enough material for it to be big and bright like that. And this is even harder to predict. So a little bit of caution right there, but it's worth going out to check out, to say maybe we will see this big meteor shower. If it's enough meteors, we'll call it a meteor storm. We might see a whole bunch of meteors on the night of May 30th. As soon as it's dark on May 30th, go out and start looking. The radiant is going to be high overhead. Now, it turns out that the radiant was defined, this Tau Hercules, where this radiant was supposed to be, was calculated in 1930 when the comet was first discovered, sometime around there. And now, with this, the way the material's been ejected and the way we think, it's going to be across the border here into not Arcturus, that's the bright star in Boötes. It's going to be across the border into Boötes here. But still, this region of the sky is very high as it gets dark for northern observers like myself. And by midnight, it's going to be really well placed. But sort of as it gets dark from 9:30 to 2 in the morning, it's just a fantastic time. We don't have a ton of moon. The moon is new, and so it's going to be dark. So if they exist, this could be a spectacular show. If they don't exist, if they don't turn up, then go back for sure and watch last week's video when we talked about the things to see across this region of the sky, including the globular clusters in Hercules, M92 and M13, and 44 Boötes, the double star over here in Boötes, and just a wonderful region of the sky to check stuff out. And go ahead and spend your time doing that. And as the morning comes, as we start to roll around toward morning, and you've spent all night enjoying observing the sky like this, then even if the meteors don't show up, don't be disappointed. Don't get too pumped up about this thing to say you're going to be disappointed if the meteors don't arrive. Get out and check this out, and to say, you can see the planets. The planets are still there in the morning sky that we've been talking about all year, basically. They're starting to separate quite a bit. There's quite a bit of separation. But right now, Mars and Jupiter are right next to each other. So in the morning sky, just before it starts to get dawn, check out in the eastern sky, Jupiter and Mars right next to each other. Saturn is a further around onto the west, and Venus is getting closer to the sun onto the east. And so they still make a nice line across there, spreading back out from that tight grouping that we had earlier in the year. But they're worth checking out. So that's your thing to do this week. Look for the Tau Herculid meteor shower. Whether it happens or not, it might be spectacular. It might be the most spectacular meteor shower you've ever seen. It might be nothing. Absolutely nothing. And whether it happens or not, be sure to check out the region of the sky. Go back and look at the things we suggested to look at in this region of the sky from Boötes into Hercules. And then stick around and watch the planets in the morning sky, and spend the week taking a look at those things even after. That's Monday night into Tuesday morning that we're talking about looking for this meteor shower. So even after that, enjoy this region of the sky. And that's what I got for you this week. I hope you have a great week, everybody. And I hope you have some clear skies and have a chance to maybe see these meteors. And as always, thanks for watching, and we'll have something new for you next week.